In this presentation, I'm going to introduce and motivate the use of network flows to actually augment the data, the monitoring data that you can obtain, for example, with SNMP. And in the second part of this presentation, I'm going to show you a couple of applications, nprobe and ntopng, that are actually designed to do this kind of flow-based network monitoring. But first of all, let me spend a few words on ntop. ntop is a private company that has been around now for 20 years, and we have the research and development in Italy and the sales in Switzerland. And we basically implement and develop applications for network monitoring. Our applications are integrated in commercial hardware appliances, but they also power third-party software applications, including intrusion detection systems like Suricata, Snort, or other kind of applications such as traffic generators or traffic analyzers like Wireshark. So they have integration also in other third-party applications. Well, we have several products available, and our products range from the low-level accelerated network card drivers to accelerate the capture of packets, and they go up until the web-based visualization tool to visualize and analyze monitoring data. And today we are going to see ntopng and nprobe. Okay, well, we are here at the CheckMK conference, so you know better than me how important it is to monitor an IT infrastructure. And monitoring the network is not an exception. It's important because if you can monitor your networks, you can control it, you know what's going on. If you have troubles, you know how to solve them. So let me take these graphics that I've found in the CheckMK sites. So with this, in this architecture, we can see how network monitoring is performed with CheckMK. With CheckMK, you have basically two things. You have SNMP, and you can use SNMP to talk with your switches and routers, or more in general, all the devices that doesn't support a CheckMK agent. And you can also use active checks, such as pings, DNS queries, HTTP requests. So today we are going to see how we can complement and augment this kind of monitoring that is already available in CheckMK. Let's start with SNMP. SNMP, with SNMP you can query basic measurements from your network devices that include the bytes sent and received on a port, or you can check the port status if it's up or down, or you can see the interface speed. This is fine because you can create alerts, for example, based on thresholds. You can say, if the interface is above these thresholds, then I want to receive an email, or if this interface is down, I want to receive a notification. Well, this is good because it provides you with visibility on the troubles. But there is something that is missing and is the cause of the trouble. So if you have a link, if you have an interface that is congested, it would be desirable to know why that interface is congested. Is there a bad guy that is doing too much traffic? Are you under a denial of service attack on that port? So it's important not only to have a notification on the trouble, but also to understand who is the cause of the trouble. The other part is the active measurements. Active measurements such as ping, HTTP requests, DNS queries. They are very useful. We have seen a real example yesterday, for example, during another presentation, but they provide a view that is somehow biased, because it's a view that is related to the observation point. Because if you ping a web server and you measure the latency or the packet loss, that measurements are related to you and not to the end customers. So they are not measurements, they are not metrics that are related to the end users, to the quality, to the real quality of experience of the users. They are measures that depends on you, that depends on the observation point. So what is missing today? Well, we can try and add some extra information to SNMP and the active measurements. And how can we do that? We can do that using adding basically network traffic visibility to our monitoring infrastructure. And it would be desirable and even better to add some kind of mapping between the traffic and the network devices. Because again, if you see that one of your switch port has an issue, you would also like to be able to see the traffic that is traversing that port now. So if we can augment SNMP and active measurements with traffic visibility, so we can create monitoring infrastructures that are somehow more representatives of what is going on in the network, and we can also pretend to be the end users, because if we see the packets, we can create custom measurements such as round-trip time, calculations, latencies, that actually reflect the quality of experience of the user. So how can we add the traffic visibility to our network? Well, fortunately, there are several technologies that comes into play and that can help us in doing this. These technologies are the most widely known and available technologies to do this kind of monitoring, to provide network visibility, are Netflow in its various versions, V5 and V9, IPFix in your routers, and SFlow, which is another network visibility technology widely available in switches. Sometimes, however, it's not always possible to use these technologies because maybe your routers and switches doesn't support them, or maybe because you need to monitor and capture real traffic packets in order to build custom measurements, such as here round-trip time, network latency, and list the deep packet inspection. And then I will spend a few words later in this presentation about the deep packet inspection, which is a technology that allows you to uncover the real application protocols that are traversing your network. So when you can use Netflow or SFlow, then you can still perform a flow analysis. You can still provide network visibility to your network, but you need an extra piece of software, which is called, in the network parlance, is called a probe. And you can feed a software probe either using switch mirror ports or even network taps. So all these technologies have something in common. They have in common the necessity to somehow compress the packets. Nowadays, 10 gigs or even 40 gig links are becoming commodity, I would say. So it's not always practical or feasible to do our analysis on the network packets, because we are talking about tens or even hundreds of millions of packets per second. So no analyst can start the analysis using network packets. I'm not saying that network packets are not important. They are important, but they are the last resort. So you need an analysis tool, and then drill down, and only eventually you have to use packets when they are just a few. So this necessity to compress packets has been solved by these technologies introducing the concept of network flow. A network flow is basically a summary of a series of network packets, a summary that carries relevant information of that series of packets. But so the formal definition is a flow is a set of packets that share some common properties, such as, for example, the source and destination IP address. But let's see an example, which maybe is easier. A web session is a network flow. And in a network flow, you have a source host, 1234, that fetched the website ntop.org. And the website has been served by this host, and the transfer took S seconds. So this is a summary of a web session. You don't need to see you need to see the packets, but you don't need to have all the packets in your hand to know that this web session has happened between those two guys. Then you can also add network latency, application latencies, TCP statistics, round trip time, but those are extra metrics. The basic flow is one such as this one, such as this. Other examples of network flows are an SSH transfer, or a video on YouTube, or an FTP transfer. So they tend to represent the logical interconnection between a client and a server. Let's see it with an example. So this is a capture that I've executed using Wireshark. And it contains all the packets that are actually 27, all the packets that are necessary to simply fetch the content of a web page. So as you can see here, we start with a TCP three-way handshake, since in a CAC, then we issue an HTTP GET request. And we start receiving many packets with chunks of the response, until the end with the TCP FIN-ACK that actually closes the connection. Well, 27 packets only for an HTTP connection. It's infeasible by a human to manually do any kind of analysis using packets, at least in the beginning. So here we have an example of the net flow that corresponds to all those packets. The net flow collapses all those packets into a single line that gives, however, you the relevant information, such as client and server, the application protocol, which is HTTP, you know the total bytes transferred over this conversation, and you can even see the content of the GET request. But I mean, it's pretty easy to see that it's a good way to condense all the network packets into a single line. Let's try now to create a connection to see how we can relate a traffic flow with SNMP. So with SNMP, you have basically information on bytes and packets counters and the input and output interfaces. Well, if you can use flows to monitor your network, then you have an extra series of information elements available to improve the monitoring. You have, for example, the source and destination IP addresses. You can see the source and destination ports. You can have quality of service metrics to see if TCP sessions are slow or fast. Or you can augment flows with routing information, maybe for traffic engineering purposes. So from the SNMP, we can add a lot more information elements. So what we can expect from a flow analysis? Why I should do a flow analysis in my network? Well, first of all, you can identify the heavy users, so the top talkers. If your network is slow, you can use the flows to see who is doing the most traffic and immediately identify an host. And when I say identify an host, I mean with an IP address. And you know that IP address is creating maybe a congestion in your network. Similarly, you can highlight the sources and destination of network traffic. That is, the traffic in your organization is going, where is the traffic belonging to your organization going? You can do this in terms of hosts, or even in terms of autonomous systems, or even in terms of countries. So you can maybe discover that there is a file transfer from your company to China, and you don't know why. Why is someone uploading a file to a Chinese host in my organization? And if you have NDPI enabled, you can also do studies on the application protocols that are used in your network. So you can quantify the volume of Skype traffic that is flowing in your network, or maybe the volume of recreational traffic such as Facebook, YouTube, and Netflix. You can do this kind of analysis. You can also uncover, doing more quantitative analysis, qualitative analysis, you can also uncover suspicious traffic. Because with DPI, you can see, for example, if someone is doing Tor or VPN in your network. Well, from a network perspective, doing Tor or VPN is completely fine. The network is working. Tor is working beautifully, but someone in your organization is doing Tor. Is this okay? Is this allowed by your policies? I don't know. It's something that I think this should be highlighted and investigated. What not to expect from a flow analysis? Well, flows don't carry information on the layer 2. So you don't see the interface status, you don't see the interface changes, or the link load statistics. But fortunately, you have SNMP for that. So we will see later in the second part of this presentation that combining SNMP with flows can give you extra information to diagnose the issues that you can have in your network. So what pieces actually do we need? Let's say, okay, I want to do flow analysis of my network. What pieces do I need to perform this kind of flow analysis? Well, if you have routers that speak NetFlow or switches that speak as flow, then you need a collector. That is a piece of software that speaks with all your routers and gather their traffic information. If you don't have these technologies in your network, or you want to monitor the packets, then you need a piece of software which is called a probe. A probe basically captures the traffic packets that are flowing in your network and converts them into flows, as we have seen earlier in the example. And eventually, you need a tool to perform the analysis, because if you have the flows but you don't have anything to look into them and to analyze them, then they are worthless. So you need a tool that is able to get these flows and put them in a way that is useful for the analyst. So in this part of this presentation, I would like to show you nprobe and ntopng. That nprobe is both a collector and a probe, while ntopng is the visualization tool. nprobe is a collector that speaks a lot of NetFlow versions, including v5, v9, IPv6. It can also work in probe mode, and currently it can go above 10 gigabit per second in terms of speed, of packet capture speed. And it not only speaks NetFlow with your routers, it is also able to deliver the NetFlow in a standardized format to multiple downstream applications, including big data stores such as Elasticsearch, or a messaging system such as Kafka. So let's have a closer look at the two ways of operation of nprobe. As I said, it can, regarding its input, it can work either as a collector or as a probe. When it works as a probe, then you have to connect and to deliver nprobe physical traffic packets. If you use nprobe as a collector, then you just have to instruct your routers to export NetFlow traffic towards nprobe. If you can use nprobe in probe mode, you have the bonus that you can perform deep packet inspection. So deep packet inspection is a technique that allows you to investigate the payload of the traffic packets that are flowing in your network. Maybe all of you are familiar with HTTP servers. That HTTP is a protocol that by default runs on the well-known port 80. But what happens if you run an HTTP server on port 3000, for example? Well, it happens that this means that the naive port-based protocol detection is no longer that useful to uncover the real application traffic that is performed in your network. In order to be sure that that is HTTP traffic, you have to inspect the payload of the packets and look for an HTTP request. So if you see the get HTTP 1/1, then you know that is an HTTP request. But you cannot just rely on the ports. Another reason why DPI is important is because it provides, it's because recently the network application developers there is a trend to reuse HTTP to develop new applications on top of HTTP. Because HTTP is a well-known protocol, it's supported everywhere. So why should I reinvent a new protocol? I can just use HTTP and implement my own network applications on top of HTTP. So with DPI, we are able to go even further and even dissect the HTTP to tell you the real application that is being used inside the HTTP. For example, this is HTTP of a video streaming service, or this is HTTP that is sending you Amazon content. Currently, the protocols that you can detect using NDPI are more than 240, and the deep packet inspection library is called NDPI, and we are the developers and the maintainers of this library. It supports more than 240 protocols, so you can detect Skype, WhatsApp video, WhatsApp voice, Facebook, Google, Amazon, Netflix, YouTube, and so on and so forth. So regardless of the input mode of nprobe, that can be either a collector or a probe, so from that point on, nprobe only has flows in his hands. So it doesn't matter if those flows has come from traffic packets or if they has come from NetFlow. From that point on, they are just flow. And nprobe can export, actually, flows into standardized versions toward multiple applications. Here I can mention here MySQL, Elasticsearch, and Apache Kafka. But you can also use nprobe to, in turn, export to additional NetFlow collectors. So nprobe is a NetFlow collector per se, yes, but it's also an exporter. So maybe you can do NetFlow conversions from version 5 to version 9 and vice versa. You can do JSON to syslog or even plain text files. We also support a messaging system which is called ZeroMQ. It's basically a publish-subscribe protocol. So you are free to create your own applications that connect to 0MQ to nprobe over 0MQ. And we used 0MQ also to speak with ntopng, which is our monitoring, our visualization tool that I will show you in this last part of this presentation. So again, ntopng is a monitoring tool capable of receiving the traffic from nprobe and to basically visualize it through a web-based GUI. So you just access your browser, you point it to the ntopng ports, and you see the results of the monitoring. What are the main features of ntopng? Well, the features that I would like to mention here are an embedded alerting system that has several external endpoints, including Nagios, Slack, so you can receive alerts directly on your smartphone. It's also a Grafana data source. And we are now actively developing the support for InfluxDB and Prometheus. It can perform active and passive network device discovery. So we have implemented several techniques to discover the devices that are attached to the network and maybe that are silent. So we will try, with ntop, we probe. We send probing packets to discover all the devices that are present in your network. So this is particularly useful, for example, for inventory purposes. And well, yes, of course, via nprobe, it also supports Netflow and sflow. This is the main dashboard of ntopng. This screenshot the screenshot that you are seeing here is a real traffic of a probe that we have installed in the MIX, which is the Milan Internet Exchange. And as you can see from this dashboard, you immediately have visibility on the top senders and the top receivers of your networks here with their volume of traffic. But you also have visibility of the application protocols that are performed in your network. So here we see, for example, Google traffic in blue, then we see Quick traffic in orange, and even Facebook traffic. You have a live view as well as an historical view of the traffic, of the application protocols, as well as the traffic on the network interface. So that measures the load of your interface over time. But I would like to show you an example now of how you can use ntopng to monitor SNMP and to augment SNMP with flows data. ntopng supports SNMP devices. So if you have your SNMP devices, you can add them, and ntopng will start to do periodic polls of these devices to create charts, traffic charts for all the interfaces. For every device that you are monitoring, you have all the interfaces available. And you can filter them, for example, for interface type. You can see the interface that are generating the most traffic. You can see the last change. You can create alerts if an interface status change. But the most interesting part here is that ntopng allows you to combine the data from SNMP with the data of the flows. Indeed, for every router that you have in your network, you have the router IP address and the flows it is sending, but you also have the details of the SNMP of that device. So why this is useful? Because let's say that you are receiving an alert in your checkmk that is telling you one of your interfaces of a router is congested. You receive the alert in checkmk, And what you can do is to, well, I have an interface that is congested. What's going on? At that point, you can jump to ntopng, pick up the router of interest. In this case, is a switch. In this case, is a switch, but you can. The reasoning is the same. You pick up the exporter, and you immediately have visibility of the flows that are traversing your device. So at that point, you can do an extra level of filtering, and you can choose the input and output interfaces. So if you know that the congested interface is an interface with index 3, you can select index 3 as input and output interface to actually see the flows that are causing the congestions in your interface. In this case, you see this is the net flow visibility that shows some DNS flows. This is a normal status, but if your interface is congested here, you will see the nature of the flows that are causing the congestions, and you will also see the client and the server. So if you know that there is a bad guy that is congesting your interface, you can go and knock to his door and say, hey, what are you doing? So this is the connection between SNMP monitoring and flow monitoring. The last thing that I would like to show you is the alerting engine that ntopng supports. Of course, it's not even close to CheckMK in terms of flexibility, but still you can define alerts for an host in terms, for example, of volume of traffic per minute, or maybe per 5 minutes. So if you know that you have a critical web server, you can set a traffic alert for your web server that it should be always at least X megabit per second. Otherwise, that could represent an anomaly. So you can set alerts on the volume of traffic, of peer-to-peer traffic, DNS traffic, and all the other kind of traffic as well. The other alerts that you can set are, for example, the number of flows generated to identify if you have flooders in your network. So if we have someone who is performing scans. So you can set all those thresholds globally for all the hosts or on a host-by-host basis. We have a basic dashboard for the alerts that shows you the duration. You know, if the threshold is exceeded, our dashboard will tell you how long the threshold has been exceeded. You see the condition, the threshold, and you see this kind of information. But it's important, and it's important to see that the alerting engine embedded in ntopng supports also external alert endpoints. So you can send your alert to Slack and email, and currently we support Nagios. So this is a screenshot that shows the Nagios dashboard with alerts generated by ntopng. So this means that this network, 192.168.70/24, is exceeding a threshold set for the egress traffic over a minute. So this means that this network is sending too much traffic towards the outside. Well, I wanted to show these because we are integrating with Nagios, and I hope that also with my visit here now and my conversation with the CheckMK team, we would like to investigate and see if we can actually expose somehow our alerting engine towards CheckMK as well. Well, I think it's time for me to wrap up. As a take-home, I would like to remark that SNMP monitoring is useful, but you can add a new metric, new information, if you combine and complement SNMP monitoring with flow-based monitoring. Flow-based monitoring, you can do flow-based monitoring if you have NetFlow devices, or you can do flow-based monitoring using a software probe, as we have seen. And eventually, you need a good visualization tool, such as ntopng, that allows you to visualize the monitored data. And I forgot to mention that we have Elasticsearch as well. We support Elasticsearch, so I would like to connect to the presentation that we have seen earlier this morning. You have bit.mk to send the checks of checkmk to Elasticsearch. So you can use at this point nprobe and its export plugin to Elasticsearch to send to Elasticsearch not only the events and the checks of checkmk, but also the NetFlow. And at this point, they mentioned the Logstash. You can use Logstash to combine the events of checkmk with the flows from nprobe to combine them into single entities that you can push to Elasticsearch. In this way, you will end up in having full visibility, both of checks and real NetFlow inside your Elasticsearch, Logstash, Kibana suite, for example. So, well, I think that's all for now. Okay, if you have questions, please.
When you send your stuff to Elasticsearch anyway, what's the advantage instead of using Packetbeat?
Packetbeat reaches much lower speeds. Yeah, it has a much lower throughput. Anyway, that's a good question. Yeah, it's a matter of throughput. Yeah. Anyone else?
Hi, one question here. How is ntopng storing the data of the flows?
Okay, it stores time series data on a per host basis, for example. So for every host of interest, for every IP address, it stores a wide range of time series data. And currently, they are stored using RRDs, so round-robin databases. But we are also adding support for InfluxDB and Prometheus. If you want not only to store the time series of your hosts, time series that are not only limited to bytes and packets, but are time series, for example, for the application protocols, so that you can investigate and analyze the historical behavior of an host and see if it was doing suspicious traffic or it was doing Tor traffic. If you want to go beyond this time series, you can. We also export to MySQL, so from ntopng to MySQL. And if you add MySQL support, you add the ntopng becomes able not only to store the time series, but also to store the raw flows that it has received from nprobe. Of course, storing raw flows, depending on the scale of your network, is challenging, and this is why we are also trying to replace MySQL with a special purpose database that is meant to store network flows, because in real networks, we can easily reach tens or even 100,000 flows per second. So in this case, MySQL, at least MySQL with a single instance, is not an option. It will choke after a few minutes.
Okay, thanks. Okay, wenn es keine weiteren Fragen gibt, dann danke ich dir, Simone.
Thank you.